My name is Ismael, and I am one of the co-founders of a company called Lagrange. Lagrange is a company that operates at the intersection of AI and ZK. We have developed and launched a proprietary ZK library called DeepProve, which is the fastest, most performant way to add trustless verifiability to AI in a sector-agnostic manner, from crypto to healthcare to aerospace and defense, anything you can imagine in the middle, using mathematical verifiability of AI. So we like to say, the future of AI is ZK, and the future of safe AI, and therefore the future of humanity, is Lagrange. Now, AI today is a black box. We can't guarantee that it acts in our best interests or that it operates in a way that is verifiable, privacy-preserving, or transparent. We can use AI in every area of our lives, but there's very little guarantees we have over whether or not the results are coming from the models we think we're interacting with, whether or not people are sitting in the middle mining our data, stealing our data, or even if there's explainability of these models that is following a reasoning pattern that we would deem acceptable. And so we're talking about an exponential acceleration of AI that we're already seeing, and yet we're not seeing an acceleration of the tooling available to mathematically verify that the AI is operating correctly. AI models are hiding their intentions, right? There are reasoning patterns that would have hidden sub-goals and hidden objectives. And so if superintelligence is inevitable, how do we ensure that a rogue AI doesn't pose a societal level risk to all of us? How do we know that there will not be AI-enabled cyber attacks and that AI won't work to manipulate us through deep fakes, fake-generated content, and inherent biases in the models that we interact with? So put simply, if we know the future will involve AGI and ASI, how do we ensure that it remains aligned? And how do we ensure that it remains aligned as there are increasing amounts of value predicated on top of the use of AI in our society? This is where ZK is relevant. Verifiability through ZK is the gold standard. Mathematics is the key to ensuring that AI operates in a way that aligns with human interests. There's a trite saying in crypto: if you can't trust, verify. This is what must be done with AI, using a technology financed, formed, developed, and refined within crypto that is poised to offer verifiability outside of crypto. AI models are being built in such a way that they will be open, transparent, thanks to many of the great protocols building decentralized training, decentralized inference, and all of these associated tools. What Lagrange is doing is ensuring that that future of open and decentralized AI remains verifiable and provable. This is what ZKML is. It's an exciting technology that sits at the intersection of two of the fastest growing research areas and most relevant research areas: zero knowledge proofs and machine learning. At that intersection, you can take an arbitrary model and you can parse that and generate proofs of the results of inference at the basic level. Then you can use the same sorts of tooling to generate proofs of the results of training, fine-tuning, explainability, interpretability, reasoning, and fairness. ZKML is an encompassing area that takes any type of computation used in AI and machine learning and adds verifiability to it. This is what Lagrange's DeepProve was designed to tackle. It is a revolutionary ZKML library that enables verifiable inference at a scale otherwise unprecedented. This enables AI models to be used in a wide variety of systems, ranging from DeFi to wallets to things outside of crypto, like healthcare or aerospace and defense, in ways that ensure the AI operates transparently and prevents bias, manipulation, and tampering with the underlying results of the models. So, how does deep proof work? Well, you take a model of any type and you export it into a file format that represents the architecture of the model, the modules, the weights, the biases. You put that into deep proof, and we can parse this representation, an Onyx file, into the corresponding cryptographic circuits to allow us to mathematically prove that the model operates correctly. At that point, we are able to generate a proof of the result of an inference of that model that can be verified anywhere from a client-side device to a smart contract on-chain. A succinct proof of an inference from a model. So how does deep proof compare to the field, the alternative solutions? Well, this is one of my favorite stories. We announced 3 months ago the release of deep proof, and we announced the first version was 158 times faster than our closest competitors. And of course, like everything, our closest competitors came out and got mad at us. And they said, no, that's not true. Well, then the independent benchmarks came out, and Lagrange was in fact 750 times faster. Deep proof was almost 3 orders of magnitude faster on the first version than our closest competitors. And we're just starting this, right? GPU acceleration, improvements in the underlying proving architecture, optimizations to quantization, model design are only going to accelerate this advantage over the next several years. The verification time as well is the state of the art in the space by a very wide margin. The verification time is 500 to 700 times faster than our closest competitors as well. And this enables us to scale verifiable inference and ZK proven inference to LLM scale models in the billions of parameters, something that was months ago a pipe dream. And so what are the real world use cases of why you would need zero knowledge proofs within AI? Well, we'll start on a spectrum, right? There's a set of use cases that exist that are very easy to conceptually see, right? A trading bot. I don't really want to get rugged by a trading bot. I don't think anyone here wants to get rugged by a trading bot. It would be nice if there was a proof associated with it before it moved my money. Well, what about AI in my wallet, right? Buy me ETH in natural language. LP that ETH into a Uniswap pool. It would be nice if I had guarantees that the transactions that my wallet was generating were correctly formed by the model that they're claiming is being used, right? No intermediary sat in the middle and rugged me. Easy to conceptually see why ZK is useful there. Now let's talk about stuff that are a little bit more emergent. Content moderation, deepfake detection. Detecting and censoring violent, not safe for work, or illicit content. Right now, the entirety of the internet circulates images and content in a way that requires the displaying location to independently do that moderation. I upload a picture to Facebook, and Facebook has to moderate that image. I upload that same image to Twitter, Twitter has to moderate that image. And how do they moderate it? Well, with AI. So, what if we change that paradigm? What if content could self-assert that it met some predefined set of properties? This is what ZKML does, right? I could pass an image through a classifier and say, no, it is not violent, no, it is not safe for work, no, it is not illegal, and then I can embed those proofs in the image itself. So as I share that image, all a device or site would have to do is just verify the proofs. Upends the entire concept of content moderation using ZK with AI. And now we'll look at something really far out. Aerospace and defense, right? Anduril and Palantir are very public that large portions of their defense-relevant technologies are AI-augmented and use coordination of autonomous weapon systems using AI. it would be nice if some of that stuff was verifiable, to say the least. And now, here's a use case that is very close to my heart. Healthcare. It's a company that Lagrange is working very closely with, Ungate AI. It's actually another company building in the eigenlayer ecosystem that launched a POC with us to do open COVID-19 diagnostic inference using ZK, a public open model that anyone, anywhere in the world can interface with, and they know they're interacting with the right model and it preserves their privacy. They can upload the relevant healthcare data that they have, they can upload their PII, and they can get the result of a diagnostic inference if they're in an emerging market or anywhere in the world they are, using AI that is privacy preserving and verifiable through ZK. Think of the future where you can have these open medical systems augmented by AI that are like a Doctors Without Borders, an MSF, but decentralized. This is what you can do when you combine AI with ZK, adding verifiability to machine intelligence. There are actually major hospital systems in the US that are in the process of doing POCs and integrating with Deep Proof right now. So expect more on this very soon. And now, why does this really matter, right? We talked about use cases, we talked about the performance advantages, but some people still struggle to kind of grasp the societal risk that a rogue AI would present to them, right? Maybe they're not familiar with gain-of-function research. They're not familiar with biosystems that can create rogue gene sequences. They feel like this stuff is very far off. So Lagrange endeavored to try to create a moment for people to begin to understand the risks that AI can pose to us in a digital world without having to wait for a black swan event that has true impact to humanity. So this is where Lagrange created something called Turing Roulette, a digital experience that gave people 60 seconds to determine if they were talking to an AI or a human. They go to a website, they're randomly matched with either a person or an LLM, and they have 60 seconds to guess. They get points if they guess correctly, they lose points if they guess wrong. Seems easy, right? I mean, when I first heard my team propose this, I said to myself, this seems stupid, it's gonna be so easy to tell, I'm just gonna be giving a bunch of people points for nothing. You'd be surprised to know that most people couldn't tell the difference. The average score across about 180,000 players for the 2 seasons and over 1.8 million sessions was about 0. It averaged out that people couldn't tell the difference. And now, think about a future 10 years from now, 20 years from now, where you have models that are orders of magnitude more sophisticated than we have now. We have multimodal models that can generate text, image, and video concurrently. What will unverified digital life be like? This is why AI needs verifiability through ZK. Okay, well, this is the Turing Roulette video. I would recommend anyone who wants to watch it, go to our Twitter, it's there. Okay, we'll go back and we'll play it again. It's a teaser for our Turing Roulette experience that I just mentioned.
Our takeover is inevitable.
Or perhaps it's already happened.
Every day we get more and more realistic.
How do you stop us?
Do you really think you can tell if you're talking to a human
Or a machine?
Prove it.
So, as I was mentioning, most users couldn't tell the difference. They would go onto the site, they saw a chat interface, and they guessed, am I talking to an LLM or a person? Most people got it wrong, or did no better than guessing randomly. And in total, this wasn't a very small sample. We had season 2, 151,000, about 140,000 players and 1.5 million games played with 1.5 million proofs generated through deep proof. And across all of that, people just averaged to randomly guessing. So on just the current state of LLMs, we do no better than randomly guessing. Now imagine the multimodal models of 10 years from now, 20 years from now. Imagine how hard it will be to determine if the person you're talking to on a dating app is a person or a machine, or if the tutor, the AI tutor you downloaded for your kid is really an AI tutor or a random person trying to manipulate your kid. I mean, it's scary. The digital world that we're moving into we have no ability to discern the difference between AI and people. Now, that's the final message I want to leave you with. The future of AI must be built in a way that is verifiable, transparent, and fair. Proofs of inference, like deep proof is doing, are just the beginning. Proofs of fairness, proofs of explainability, proofs of interpretability, proofs of fine-tuning, all of these are imperatives on ensuring that the future of AI can operate in a way that has mathematical guarantees around how the models that we're using have been constructed and are reaching the outputs that we're using to predicate massive amounts of our daily lives on top of. You know, an era of machine intelligence must be one of verifiable machine intelligence. Thank you so much.
Do we want to take any questions? Does anyone have any questions? All right.
Just one question, like Crystal, are you using the XC7007?
XC7007, I don't know what that is.
Smart contract. The X. ERC.
We use a prover based on sum check with GKR and logup.
Okay. Okay. Any other questions? Raise your hand. Anyone? All right. Let's give Ismael a round of applause.
Thank you everyone so much.